Okay, for those of you that need a little refresh on factoring, these are the simple factoring problems. They are in the form ax squared plus bx plus c, but the ones that I've given you to practice, you'll notice that the a value is always 1. So there's nothing written in front of our x squared, which makes these easy factoring problems because we don't have to do guess and check or factoring out a GCF. So when you're doing factoring, what you're doing is you are unfoiling a quadratic. So you're taking a quadratic and you're unfoiling it into two binomials. Okay? Now, to know what goes in each of those binomials, you do have to look at the terms that you're given. For example, the two last numbers have to multiply to get me 2. So you want to think about your factors of 2, which would be positive 1 times a positive 2, or a negative 1 times a negative 2. And then you have to think which of those would sum to get me my b term. Well, to add to be a positive 3, that must be a positive 1 and positive 2, which means we'll put an x in the first spot of each binomial. And then it doesn't matter if you put plus 1 here or here, but we'll put a plus 1 and a plus 2. And then you can always check by foiling. We'll get x squared plus 2x plus 1x and plus 2. And you can see 2x plus 1x is 3x. So this was my final answer, factor. Okay, so that's how you're going to do all of these. You are listing the factors of the last term. Let's take a look at this one. So our factors of 40 could be 1 and 40, 2 and 20, 4 and 10, or 5 and 8. Okay, these are numbers that multiply to get me 40. Because the last terms always multiply to get you your constant term. Which of those would sum to get me my middle term? Well, 2 and 20. So we factor this down into x plus 2, x plus 20. Again, always check by foiling if you're not sure of the answer. Now up here in the example, you can see that sometimes the last term is not a positive number. It's a negative number. So when you're picking factors that multiply to 72, one of them will have to be negative. So you can see one example is negative 1 and positive 72, negative 2 and positive 36. But technically there's an alternate option here that it could be positive 1 and negative 72. So when you see a negative at the end, that means the signs are going to be different. And really, you're going to have a lot more combinations of numbers to inspect. Okay? Now, we want them to multiply to get me negative 72, and we want those numbers to add to get me a positive 14, which means the larger number needs to be positive so that we're really subtracting the other number to get and have it to be, say, 14. So you can see these would never add to be 14. These would never add. Oh, but these would. Negative 4 and a positive 18 would work. So this would factor in to be x minus 4.
Excuse the interruption. Just a reminder, all members of FFA should be down in the gym lobby for the picture at this time. Thank you.
Okay. Now, all of these are pretty much the same thing. Let me just pick another one. Sometimes you will see different signs. So let's do 26. So again, we're thinking about factors of negative 40. So that would be like negative 1 and 40, negative 2 and 20, negative 4 and 10, negative 5 and 8. But we also could inspect, I'm not going to write them all out, but we could inspect positive 1, negative 40, and so on and so on and so on. Which of these pairs of numbers would add sum to get me my middle value of a positive 6? Well, 10 minus 4 is 6. So when you do this binomial, instead of putting x and x, since it was d squared, this will be d and d. One will be a minus 4, one will be a plus 10. And you can double check d squared plus 10d minus 40 gets me 6. Negative 4 times 10 is a negative 40. On the back, you will see some that have multiple variables, such as an x and a y. So let me do number 34, for example. we see x squared plus 12xy plus 35y squared. So we have an x squared in the front and we have a y squared at the end. All that tells me is that when I factor this, each binomial is going to get an x and a y. That way, whenever I FOIL this, I will get x squared when I multiply the first terms together, and I will get y times y, which will get me y squared. Everything else works exactly the same. We're looking for numbers that multiply to be 35 and sum to be 12, okay, which is obviously going to be 5 and 7. 5 times 7 is 35, 5 plus 7 is 12. So I'm just going to throw in a positive 5 and a positive 7. And then you'll see we'll get x squared plus 7. Now you can write it as yx or xy. I usually put it in alphabetical order because multiplication is commutative. You can switch those around. Plus 5yx, or again, you can write that as xy, plus 35y squared. Again, when we add our like terms together in the middle, we will get 12. So this is our final answer. All of the other problems should be exactly the same, so give them a try, and we'll see how you do tomorrow.